Across the parking lot from Building 16 is the data center. You are now seeing Building 14, where the director of the data center and his staff reside. This includes systems operations, hardware planning and installation, performance and capacity planning, systems and programming, data management, network operations, and network software. Adjacent to Building 14 is the data center. The personnel turnstiles to the data center are controlled by an access card system that is located in the security guard station, which is the hub of the physical security efforts for the data center complex. From this location, all the fire detection and fire suppression equipment is monitored on the panel shown. In the event of an alarm, the guard on duty can organize the required response with in-house resources as well as the fire department. The perimeter, entrances, and key points are monitored on the closed-circuit television system. The television system is interfaced with motion detection alarms and other state-of-the-art electronic security systems. All activity can be recorded, and the appropriate guard response is directed based on the input gathered by the security systems. The extensive use of electronics reduces the manpower requirements normally required to secure a facility of the data center's complexity. Emergency fire extinguishers are located throughout the data center, and air packs are on standby for use as required. The Customer Service Command Center is always the first point of contact for problem determination and resolution. The Command Center concept allows ease of communication between support groups during problem definition and resolution. Expert personnel are available to resolve hardware and software problems. Across the front of the Command Center are the master consoles. The lead operators monitor and control the host complexes and ensure timely turnaround of TSO and batch processing. Also, the IMS Coordination Center is on this bank of terminals to control and monitor all IMS transactions. The network terminal operators who work with all TP personnel locally and at the remote sites on VTAM-related problems reside here to monitor and maintain the VTAM network and document any changes. This glassed-in area is used in the event of serious hardware or software problems. All support personnel gather here for resolution of problems. Problems resolution headed by Operations and Operations Technical Support. In the tape area, there are over 250,000 tapes, 180,000 cartridge, and 70,000 reel types stored in movable racks. To accommodate the 6 MVS operating systems, there are 64 cartridge tape drives with 24 autoloaders and 25 reel tape drives. To accommodate the VM operating systems, there are 8 reel tape drives and 8 cartridge drives. The operators mount 6,500 to 7,000 tapes per day, and over 90% of the mounts are under 2 minutes. Over 25,000 tapes are in an off-site storage. We have almost 1,400 gigabytes of storage capacity in a mix of single, dual, and triple density direct access storage devices, configured in such a way as to eliminate any single point of failure except at the device level. Technology has increased storage capacity while decreasing devices. Today, we have 64% increase in storage with a 26% decrease in devices since 1986. All DASB supports 8 operating systems, 2 VM and 6 MVS on 3 3090 machines. The telecommunications technicians provide around-the-clock on-site support for the data center's telecommunications needs. This group is responsible for the overall operation of the data communication network, which includes COM10 and IBM front-end processors, multiplexers, VANs, and INWATs. There are 7 remote locations linked to the Orlando Data Center via multiple 9.6 or 56 kb trunks utilizing either wide area network, AT&T, or MCI network. A multiple C1 wide area network NUC provides connectivity between Orlando Data Center and remote front-end processors. A Bitex Auto Switch 4000 matrix switch that has 13 satellite units provides connectivity between the front-end processors and the various communication devices. The switch is also used for monitoring, troubleshooting, testing, and sparing. ODC TP operations interface with various private line carriers such as AT&T, Southern Bell, and MCI. The 3 3090E model CPUs support 8 operating systems. A 3090-60E running in partition mode, running 2 MVS systems. A 3090-40E with Prism running 2 MVS systems. A 3090-40E with Prism running 2 MVS systems and 2 VM systems with a total power of 201 million instructions per second. Again, technology has saved us floor space and environmental costs by putting more MIPS in less floor space, and they use less energy resources. The uninterruptible power system includes 600 batteries, each 4 times the size of a car battery, which can keep the data center running for 15 minutes. 1,000 tons of air conditioning, enough to cool 450 average homes. And 6 engine generator units with a total of 4,875 horsepower, which can generate 2,600,000 watts. The central processing unit chillers provide cool water for CPUs. Sensors within computer hardware and water chillers monitor the temperature and the flow of water. Concludes the data center orientation. At this time, I would like to thank all the individuals who provided me with input to put this video together, and especially Mike Camano and Mike Moody.